I'm pleased to introduce today's first presenters, Dr. Zander Evans and Mike Lynch. Zander is the Executive Director at the Forest Stewards Guild. In addition to a diverse portfolio of work in forestry and fire, Zander has long been a supporter, contributor, and board member of the Southwest Fire Science Consortium. He has co-authored the Southwest Fire Season Overview for the last decade and looks forward to speaking to you today about the 2023 edition. Mike is the Great Lakes Region Director with the Forest Stewards Guild. In his work, Mike focuses on regional research needs, collaboration opportunities, and natural resource planning at a landscape scale. In addition to balancing the multifaceted ecological, economic, and social needs of the Lake State's forest resources, he also assists with geospatial and data analysis and has contributed to the Southwest Fire Season Overview for years. Thank you, Mike, for making this possible. We're really pleased to have Zander and Mike with us today. And with that, I will turn it over to them.
Great. And I think Mike's going to pull up the presentation because he gets to do most of the slides. And while he's doing that, I'll just give a shout out to Rachel. I used to host some of these webinars, and it's nice that Rachel's doing it because she does a nice professional job. And we'll maybe leave it at that, but it's wonderful to have Rachel on, and you're probably lucky that I'm no longer doing them. So go ahead and go to the next slide, Mike. We have been doing these fire season overviews for over 10 years, and it's on the to-do list to sort of summarize some of these. We did some summary, actually, I guess it's a few years ago now at the Association for Fire Ecology meeting. So maybe we should try again this fall to do a summary of the fire seasons. So you can go back and look at past years, and we'll do a little bit of comparison just to try to put this 2023 in context, and hopefully, as Rich presents in the latter half, give you a little view of what 2024 might be and how it might be comparable to other years. Go ahead to the next slide, Mike. Not surprisingly, the 2023 was hot and dry. In a world of a changing climate, maybe not as hot or as dry as we're concerned about for the future. But these two maps just show the sort of percentage difference compared to, I believe it's the previous century. It was a little bit drier, less precipitation than average, and many areas were a little bit hotter, just a few degrees Fahrenheit hotter than past years. So that's sort of been our context for a long time. Drought was ameliorated a little bit in 2023, but still essentially ever present in the Southwest. Go ahead, Mike, to the next one. And so what we have here is what's known as the energy release component, or ERC. And not to spend too much time on the details, and Rich could actually explain it a whole lot better than I can, but essentially it's a measure of the amount of energy that a fire can release based on things like humidity and temperature. And so it's a good measure that fire managers can look at day to day to see how severe the fire season is getting in sort of simplistic terms, in my non-meteorologist terms. So one of the things we see in 2023, and that's that purple line there, hopefully it's legible for you all, is that at least for the first part of the season through April 1st, 2023 was actually below the average for the past 10 years. And then it started to climb up right around April 1st and didn't get as high as in this particular zone as the maximum, but got up there. And we have a little bit of 2024 when I captured this graph in the dark blue, and you can see already 2024 is the ERCs are higher, sort of up towards the maximum. So Rich will no doubt talk about that. We can see some dips there, and then it kind of gets back up towards the maximum late in July. And so as we go through, as Mike will talk about some of these fires in a second, you can kind of keep this in the back of your head that particularly in that July frame, temperatures got up. Yeah, and go ahead and go to 2021, Mike. And so I just put this in here as an example of a year where, particularly in that April to May time frame, the ERCs were closer to that maximum. And so, presenting more opportunity for fire growth, potentially more fire intensity at the fire line, and hence greater severity in some cases. So let's go to the summary of the fires. So we do this graph every year, and we've added another year here, 2023, and you can see that we had fewer acres of wildfire than in many of the last 8 years, even going back to the early part or the latter part of the last decade. So there were about 2,500 fires across the Southwest. Most of those were in Arizona. They burned a total of 382,000 acres. And I think it's important to say up front that not all those acres were quote unquote bad fire or high severity or anything like that. And that's part of the point of this fire season overview, to get some sense of how the severities played across the region. And I think with that, Mike, I'll turn it over to you. Are you ready to jump in at this point? I can't remember exactly what we agreed, but.
Long as I can figure out how to get demuted. Okay, can everyone hear me? Or at least can
Yes.
Zander hear me?
You're
okay.
Good.
All right, well, thanks a lot, Zander. I'll mention right off the top here that I'm in the Great Lakes. I'm based in Minnesota. So when I say something is a lower severity fire, just keeping in mind that, I'm not one that's living that exact fire. So you guys who were out there with these fires or looking at these fires certainly have a more of a in-person context. I'm looking at these over several years worth of data and kind of comparing across the data sources we have. So what we have done in the past and what we continue to do here was kind of try and find a big cross-section of the largest fires. And we have been using acres. There was a couple of years where we did include a couple of fires that had some significance near an urban area. But in general, we've been using a kind of acre size cutoff. And so for this year, we used the cutoff of 10,000 acres. And so we had 9 fires in the Southwest that were over 10,000 acres this last year. So that accounted for 187,000, and I wrote 500. It's actually like 498, but close enough. So about 187,000 acres of the total 382,000. So we're covering, about half of them. You can see on this map, this is where they're located. So we've got the New Mexico ones. There's 4 in New Mexico, and all 4 of them are in this Gila region. And then the 5 that were in Arizona were a little more spread out. We had the Beehive Fire all the way down by the Mexican border, and then the Ridge Fire up by Grand Canyon National Park. So those were a little more spread around. The data sources that we use in this report, we use the land fire data set for kind of our vegetation information. So we try and look and I'll mention these other data sets in a moment, but when we look at things like soil burn severity or canopy mortality, we're trying to look at those and connecting those with, well, what is the vegetation? Is canopy mortality in a shrub chaparral grassland type setting is a very different story than canopy mortality in a ponderosa pine or spruce fir type setting. And then we also use the land fire data for the vegetation condition class data. So that kind of gives us a sense of departure from historic conditions. Then the two main severity data that we pull in for this geospatial analysis are the soil burn severity data and the canopy mortality ravage data. And both of those can be found on this burn severity website. And you know, one of the things I tried to do here is always limit how many acronyms we have. So of course I went in to just remind myself what ravage stood for, and then I see that there's no G. It's actually, but I think that's vegetation, but anyway, it doesn't matter. So rapid assessment of vegetation condition after wildlife group. And so that's the other data set we're using there for the spatial stuff. Then we use the incident status summaries, 209s, to kind of get a flavor of how the fire was progressing each day. That gets us an idea of how we can write the narrative part for each of these. So we've got kind of a spatial component, and then we've got our data analysis, but we also try and include stuff that ties the narrative of like how the fire was progressing and some of the different values at risk and things like that. In addition to that, we include the INSEE web data, and so that gets us a variety of different things that also can allow us to get some of that flavor of each of these fires, since we're looking at them across this region. And then finally, one thing I didn't list here was just we'll end up going through and doing, you know, like Google searches, looking through kind of local media information, just to kind of additionally get that kind of cultural impact of some of these fires in the area as well. So what I'll do here is I have slides for each of the 9 fires we covered in this report, but I'm going to kind of go through, just highlight a couple of them, kind of go through them relatively quickly, because I think we all kind of want to hear Rich's information about the upcoming fire season too. So, and then one thing to note here, we always have this ongoing kind of dispute as to how, we're not going to dispute, but discussion on how to organize these. So for this, I'm going to organize these based on the start date. So the Pasture Fire, which is the first one here, was the first fire of these 9 fires this year, and then going through them in chronological order based on start date. We also, you will see maybe some of the graphs later, I have some of them sorted by size. So the Pasture Fire was actually the largest and the first to start. And then sometimes alphabetical by the name too. So a few different ways to look at it, but we'll just first hit this Pasture Fire. So this was the largest fire we had. It started in mid-May and then ended up being, so our largest fire this year was significantly smaller than a lot of the largest fires we've had, certainly last year, but then in years prior to that as well. And so this one was one of our Gila area fires, and then this one was kind of before, but then continued on into September with some of these other ones. Okay, I did click ahead. So one thing just to highlight with this fire is I put up the soil burn severity information here. So a large part of this fire had unburned, low severity soil burn severity. And you can also see what we try and do with these maps when we pull them together is include the past fire histories in the area too for the previous 10 fire seasons. So this one, there was a Black Range complex fire that had burned that same area in 2016. And you'll kind of see a continuing trend on a lot of these that we ended up with relatively low severity for a bunch of these fires. So jumping ahead to the Wilbur Fire, that fire was in central Arizona. Another lightning caused fire here. This one also was a May fire and then extended on and ended up being about 10,000 acres in central Arizona. This one also had a significant portion of it burned in 2016. I'm not sure. I think that's more correlation than anything else, that the first two both had 2016 fires. But again, relatively, this is canopy mortality. And again, a relatively low percentage of canopy mortality. You can see a few pockets here or in the, you can see the graph, or the, what am I trying to say? Legend in the right-hand side there that gives you an idea. The red being 75 to 100, the kind of darkest green being 0 or undetected, and on up. So essentially half of this fire had burned in 2016 as well. Ridge fire, so this is one up by the kind of Grand Canyon country. This one is at the beginning of June. In fact, actually looking at the date today is also the 4th, right? So the 4th of June. So 1-year anniversary for this fire. 10,000 acre fire here. And this one you can see on the southwestern portion, and this fire moved in that direction towards the southwest. And some of the higher intensities of that fire were in that southwest area. I did not include a second map for this one that showed the soil burn severity for this presentation, but the soil burn severity showed a little bit less of the kind of bright red severe areas, but that kind of circular area on the southern area was kind of the area that had the most soil burn components there. So more than 2,300 acres of this one had over 75% canopy mortality, so a little bit higher than some of the other ones we're reviewing. So here's the Beehive Fire. It has a surprisingly blurry map, but it is down in the southern border near Mexico there, starting at the end of June. And let's see what our map. So here's one. This one is a little different fuel type than some of the other ones. And you'll see here relatively high percentage of canopy mortality. But you can see in the photo to the left, this is a little different than some of our ponderosa pine fires with some of the other ones. So I included, I believe the next slide highlights, the soil burn severity for that fire. And so you can see, if I go back one, a lot of red, high canopy mortality. And this is why we try and look at 2 of these different data sources, that this soil burn severity, and it was not available for the entire fire. So that's why you can kind of see in that northern part of the fire, we don't have any data, but I'm not sure there was any area that fell into the high severity on this fire, which is a little different story than you just get from the canopy mortality. The pilot fires, so this one is more in western Arizona, starting on July 1st or July 1st of this last year. And this is one that we didn't have any soil burn severity or ravage data for. So the canopy mortality data was available for 8 out of our 9 fires, which is actually higher than we've averaged in the past. And this is the one fire that we did not have that for. So for this, I included a image that shows that vegetation departure, and I did not. It doesn't look like there's a legend here. So just to kind of highlight, green means not very departed from a low departure from historic conditions, and then on up to the yellow and red. You guys are all familiar with the stoplight. So this was had a very low, this was our lowest departure from historic conditions fire. Unfortunately, we don't have any severity data to be able to draw any conclusions on how that related to severity. I'm going to kind of just breeze through a couple of these in the Gila, but this is again a divide fire. This was one of our large, I think this was our 3rd largest fire, mid-July. Reporting dates, I guess we write start, but as reporting dates, we don't know exactly the starts necessarily. And again here, relatively low fire severity with the canopy mortality. Pasture Fire, another one in that same area, started about a week after that, the last fire. Same type of thing. You'll see these are all in kind of ponderosa pine country. Not a lot of fires in that immediate, like that exact footprint, but some of them in the same general vicinity over the last handful of years. Prior Fire, another one in that same area, also starting that end of July period at 12,000 acres for this one as well. And again, ponderosa pine, relatively low. The legend didn't reproduce on this one here, but again, the green being the lower canopy mortality. Still fire, this was our final fire of the year. So this is the final summary one. We've got a September start for this one, and this is in central part of Arizona. And you can see this area has a lot of past fire history here, with about a half of it being in that 2019 fire as well. So some overall trend information I'm going to put up here. One of the things just to highlight to everyone is ponderosa pine. So this is the vegetation we break. Essentially, land fire spits out, whatever it is, 100 different, condition vegetation types, and we summarize them into these 9 vegetation types, and then non-vegetative as well. For the summarizing this data. And this year, ponderosa pine was our most common fuel type. And so I think that relates to some of these maybe lower severity fires that we've seen. To highlight that, I compared, similar to what Zander had in his section, I pulled up the same chart from 2021. One thing to take home here, though, too, is that 2021, a lot more acres burned. You can see the even in ponderosa pine, sure, relative ponderosa pine was the highest for us in 2023, but it caps out at, somewhere in there, 84,000 acres. And you can see ponderosa pine in 2021, we were over 100,000 acres. But in that particular year, there was a lot more pinyon juniper, conifer oak, chaparral, scrub, fuel types that were being burned. And for this last year, conifer oak and scrub, we were under 10,000 acres in the 9 fires we highlighted. So kind of a comparison there. Condition class, all of our fires were, with the exception of the pilot fire, were relatively high departure from historic conditions. So the graph on the right just combines all the fires together, and seeing that high was certainly our most common. And then you can see on the left the individual fires, and that really highlights the pilot. Unfortunately, we don't have severity data for that pilot fire to really get an idea of did that make a difference or not. Hitting that canopy mortality information again, this summer is highlighting that, whatever, I forget what the exact total is, but the vast majority of our fires had 0 or 0 to 25, a less than 25% canopy mortality in those top fires for this last year. And then finally, this is one of those that a lot of times we'll try and highlight. If that past graph showed a lot of high severity in the canopy, I'll bring this one up to highlight that, well, at the soil level, depends on that vegetation type. But here it's the same kind of story. It was relatively low on the ravage, relatively low on the soil burn severity. The only fire that had, any real visible data on this chart here was the Ridge Fire. But I think if I recall correctly, that was like under 500 acres, like 490 acres. So, certainly significant for those 490 acres, but overall low severity across those. So some of our 2023 themes, weather wasn't set up for a big fire year that Zander highlighted at the beginning. Fewer acres burned in 2023 than the past 8 years. So we had fewer total acres, and then our kind of top portion of that, the top half that we highlighted, was lower as well. One thing I didn't mention in here, and you'll have to look at that report to get some of this information, is more of that narrative component that I mentioned earlier. And there we look at the 209s to kind of get a sense of how these fires were approached. And so I just put a bullet in here to mention that in, say, 2021, full suppression was listed as the strategy or approach by fire managers for nearly all the fires in that report. This one, 3 of the 9 fires had full suppression listed as the approach. And so there was a much kind of more diverse approach to fires, and that likely has to do with maybe I'll skip down a bullet. Many of these fires being in areas like the Gila, which has more of a fire history, and some of these areas were pretty remote fires this year, as opposed to some of the past ones that were approaching more human communities. And another factor I think that factors into some of these things is that we had our percentage much higher on ponderosa pine instead of some of these other fuel types. So overall, a generally low severity fire season is kind of our take home for the 2023 report. And that's the conclusion of what we have. Looking forward to hearing Rich's component for the 2024 outlook, and certainly happy to take some questions at the end if anyone has them.
All right, great. Thank you so much, both Zander and Mike, for that wonderful overview. I know that wasn't a lot of time to cover a lot of information. So I would like to turn it over to our last presenter for the day, Richard Naden. Rich is a meteorologist for the National Park Service based in Albuquerque, New Mexico. He has worked in the Southwest area predictive services for more than 2 decades and regularly presents on fire season outlooks for the coming year, providing an initial look at anticipated weather, climate, and fuels. We're so excited to have Rich join us today, and without further ado, I will turn it over to him. And Rich, go ahead and just let us know that your audio and video are working. We're not quite seeing you yet.
I can hear you great, Rachel.
Okay, great.
I'm not sure if my video is working correctly or not. Can you see me at all or no?
We can't see you, but that's all right.
I hit start video and I see something like a light come on my top of my monitor, but I'm not sure what else is going on or going wrong here. But let me try to share a screen. That's probably the most important aspect.
Yeah, sounds good. We'll just have you be our floating head today.
All righty. So let me know when you can see a blue screen.
We can see it. Go ahead.
All right, most important aspect. Good. So thanks, Rachel, and thanks, Zander, for having me. As mentioned, my name is Rich Naden. I've been part of the Predictive Services Unit since 2003. And my cohort, Chuck, who I'd been working with for 20 plus years, took a different position earlier in the past winter time. So I'm kind of a lone wolf for this season with a little bit of help from some other people around the West. So what I'm going to talk about today is kind of what the outlook looks like for this fire season. Now, I'll be up front here. This PowerPoint was updated about a month ago. So we actually have historically never done like an early June update. So typically the last update for this specific product that I'm talking about is early May, and that's indeed the case here. So that being said, I can kind of, change it up a little bit as we get, especially towards the end, and show what the most recent forecast is for significant fire potential. But a lot of the stuff I'm going to show still applies here. So, and this is up on the SWIC website. I think Zander might have thrown the link into the chat. If not, I can do it at the end. The link to this specific product. This is a bit dated here. If you look at the bar graph here, once it's up on the screen, it pretty much shows the change through the last couple decades of perspective on large fire, where we of course used to have more of a suppression-based stance for decades and decades and decades, 50s, 60s, 70s, 80s. And then the green bar is showing here back from early to mid 2000s, slowly the recognition that we needed to have a fire in the landscape, as it was for hundreds and hundreds of years before man tried to cradle everything back in the early 1900s. So that's still the case now. We do have to suppress some fires that are especially in precarious spots across the region, but in general, we're trying to make use of these fires in a lot of instances and have them be able to spread across the landscape safely and do what they need to do to restore the forest. So I'm sure when I get the updated data for this particular information here by 2017, 18, 19, et cetera, there'll be even more green for these specific years. I'll shoot for that for next year. In our region here, we're about a 50-50 split between human and lightning caused type fires. For example, in the Pacific Northwest, it's almost all lightning caused fires for their large fires. And like Mississippi, Georgia, Florida, some of the southern states, Alabama, those states are almost all human caused fires. So it's really interesting depending where you are across the country. As you might imagine, the human caused type incidents are much more prevalent during March, April, May. Coincident with windy and dry type weather. We're still kind of having that, but we're starting to get a mix right now of some moisture pulsing into the region up and down also. So that gets to the last bullet on this first slide here. Lightning caused fires much more prevalent from June onward. And again, no surprise, that's coincident with the moisture with the approaching monsoon, which is normal from July onward. So here's kind of the main things I'm going to be touching upon today. Drought, how that impacts the big picture fuels conditions across the region. The fine fuels condition. It's real difficult to kind of quantify the fine fuels across two giant states, but I'll be doing my best to do that here for factor number 2. What's been going on with temperature and precipitation the last 6 months or so, which impacts kind of the season setup. Number 4, this late spring, early summer weather pattern. This impacts fire, the ignition and spread components for the fire. And the monsoon, which is typically the end of the large fire season in our area. So real quick, with no further delay, jumping into factor number 1 here again, just keep in mind the information on the left side of the screen is about a month old. But nevertheless, upper left shows kind of a 6-month change map in regards to drought class change. The middle portion of the left side of the screen is probably something people have seen on this call, the drought monitor. National Drought Monitor looks at kind of the drought component across all sections of the United States. And bottom left is kind of the seasonal drought outlook. So just real quick, upper left to bottom left, upper left, that 6-month change map in general shows, believe it or not, improving drought conditions from a 6-month standpoint across most of the geographic area. And when I say geographic area, it's not just New Mexico, it's all of Arizona. Also, you can see the northern tier of Arizona near the Kaibab northern sections of the Coconino, for example, does have a small swath of, it looks like worsening type conditions there for the 6-month standpoint. U.S. Drought Monitor, this is a little bit different now than it was April 30th, but in general, the drought is worst southeast across New Mexico and probably least significant further off to the west, northwest across northern Arizona, even now. And the drought outlook in the bottom portion, bottom left there, kind of shows the expectation for drought persisting through late July of 2024. In general, this has not really stopped or changed with the most recent update as of late May, kind of in the same type of situation, same type of forecast there. Fine fuels aspect, as previously was alluded to back just a little while back. Last couple of years have been quite different. Last summer we had a very poor monsoon. In the summer of 22 we had a very robust monsoon. So we've seen in just the last couple of years how things can be vastly different across the Southwest area. And 2 years ago it worked out quite well. My expectation was for it to be a very robust monsoon. It worked out great. Maybe I'm just getting lucky as I get older, but maybe I'm getting smarter. I don't know. Maybe it's just a mix of both, or maybe it's just luck. But 2 years ago worked out great for a robust monsoon type forecast, and last year worked out great for a poor monsoon forecast. So hoping this year will continue the trend. But the upper portion of this chart here, or this slide, kind of shows month by month what happened precipitation-wise last summer. You can see just by glancing June, July, August there, a lot of orange and red. And that means poor precipitation. Even into September, there was even yellow and some red there across sections of the area. October also quite dry. Throw those 5 months together, upper right there, you see, very, very poor precipitation signal last June through October. So why am I talking about this? Well, a lot of the warm season precipitation in our area impacts the growth of grasses and various fine fuels across the region. So normally right away you would say, okay, well, we don't have a lot of fine fuels from last year's poor monsoon, so we shouldn't have as many problems. Well, That could be the case in some of these areas of the region, but and I'll show that here in a moment. But there's also some fine fuels that respond differently to poor monsoonal rains the previous summer and fall, and some of them respond a little bit differently to more wet conditions across the winter. So it's just not a one-on-one correlation here. Poor monsoon, poor grass or fine fuels growth for the following season. So right now, kind of the middle bullet there, fine fuel loading and continuity does range across the area from below average or below normal to above normal. And I'll kind of pinpoint these areas here in a moment. Some above normal areas right now are across eastern and northeastern New Mexico, and some parts of southern and south central Arizona are above average. I always look for input from the various units out there. Some units are great, others don't respond often or if at all. So I'm always looking for additional information from people that are out in the field. Bottom two little pictures there at the bottom portion of this slide, percentile and rank. Again, just reemphasizing in the these particular two portions there at the bottom show 125 years of data approximately, and the bottom right there shows the rank map. So we're looking at just last summer, June through October was in the top 5 to 10 years of dry in the last 125 years for that 5-month time frame. So that's quite significant, just indicative of how poor the monsoonal time frame was last year for 2023. Kind of been working with a guy from Rocky Mountain Research Station on the fine fuels aspect. I haven't talked with him in the last couple of weeks, but he does a lot of work on fine fuels and how they relate to fire season. So he sent me some maps a while back, and I spoke with him a lot on the phone. This shows what the expectation is for the summer here as we head into late spring, and now we're in the early summer of 2024. The orange and reddish, or the yellowish and orangish colors, indicative of poor fine fuels or percentage change, kind of a negative percentage change, which means less fine fuels available. So you can see a pretty good swath there from Tucson in southeastern Arizona through like Deming and Lordsburg and the Boot Hill area, all the way to Alamogordo and the Lincoln National Forest area, Socorro, towards Artesia, Hobbs, and some of those areas. So really the southern tier of New Mexico, not a lot of fine fuels expected to be in play for this fire season. Even as you head to the east, northeast of Santa Fe, there's a pretty decent area up there that doesn't have a lot of fine fuels. However, if you just look adjacent to that area, you can see the greenish areas, darker green here. And especially as you head into Texas, we had that big fire back in February, northeast of Amarillo. So those areas still expected to have a lot of fine fuels as we head into early to mid-June here. It's been quite moist there recently, so hasn't been much of a factor, but those fuels have been available the last few months. Looking further to the west across Arizona here, you can see the Phoenix area southward towards the international border has a pretty good copious amount of fine fuel growth, as does kind of the Prescott National Forest area. And anything in white here is just undetectable due to elevation. So that's not snow, that's just indicative that this particular mode that this individual utilizes does not provide data for those areas. Up towards the Four Corners, Grand Canyon area, up towards Page, Arizona, those areas also have pretty decent fine fuels as we head into the summer months here. And looking at the actual amounts here, this next glance at things, again, anything in green, dark green especially, great amounts of fine fuel or above average amounts of fine fuel. Anything in orange and in dark yellow, indicative of poor fine fuels. So you can see kind of the areas right now real quickly regionally where we would have some concern. The Gila area, perhaps, again, eastern, northeastern New Mexico, and many areas along the Mogollon Rim, southern sections of the Mogollon Rim, just to the east, northeast of the Phoenix Metro. And that's kind of a bad area over there with all the people there. And they've already had kind of a pretty active second half of May into early June in the last few weeks. So that's kind of the fine fuels portion. So completely shifting gears here towards the climate geek stuff, and I'll try to be super brief here and super simple. We are shifting right now from an El Nino episode, which we saw develop about a year ago in April, May of 23, into we're kind of ending that. We've been getting out of that the last 6 weeks or so. We're in kind of ENSO neutral right now, which means neither El Nino or La Nina. And we're headed towards a La Nina episode this coming late summer and fall. So that kind of that little arrow area there with the circle, that shows the important area in the Pacific Ocean, which climatologists and meteorologists monitor to gauge what's going on with El Nino, or also called ENSO, which is El Nino Southern Oscillation. Bottom portion of the left side of the screen here shows the forecast as of late April, early May. And these kind of shows where we were coming from back in the late winter, early springtime, kind of an above normal around 1 degree Celsius in the important Nino 3.4 area, which in the bottom right here you can see is kind of in the central portion of the equatorial Pacific. So watching the forecast expectation here in the far bottom left, you can kind of see how these temperatures are expected to continue to diminish and decrease here through the month of June into July, and then even slowly further all the way perhaps towards a -1 threshold by September, October. So this kind of tells a tale, again, with the expectation of perhaps some type of moderate La Nina by this coming fall. Upper right shows kind of a fancy trade wind index that I kind of follow and kind of create graphical information for. So it kind of does show the triple dip La Nina with those 3 circles there. That's from the winter of 2021, 21-22, and 22-23. Then here we are on the right side of the screen with this weak El Nino episode we saw in the last 12 months or so. And then far right here shows the trade wind starting to pick up once again, allowing kind of back towards ENSO neutral. So a lot of information there, but the bottom line is we are moving out of El Nino into a likely La Nina episode by late summer and probably early to mid fall of 24. I'll be a little quicker on this information because it's a bit dated here. This is just showing what went on February, April, May, February, March, April of 24. Upper left is temperature, lower left is precipitation. Most of the region had a cooler tilt temperature-wise in February, March, April. That's shown by the green colors, except for the far east and north here with that yellow showing up. And then bottom left here shows precipitation anomalies. A lot of the green and purple there shows we saw above normal precipitation for that February, March, April timeframe, especially across eastern Arizona towards the Gila area, far northern New Mexico also. But notice the big swath of dry here across the eastern third or so of New Mexico. So kind of a dry spring, late winter and springtime for eastern New Mexico. And looking at just the month of April, April saw pretty much a continuation of that cooler pattern for much of the geographic area with the green here across many portions of the area. However, looking at northward towards the border with Utah and Colorado, a pretty wide area there of above normal temperatures up there, hugging the Colorado border all the way up towards the panhandles of Texas and Oklahoma. So kind of coolish across most areas in April, but warmer across the north. Precipitation-wise, bottom left here, continue to see a wet Arizona here, or much of Arizona for the month of April, notwithstanding the far northwest and the Four Corners were below average, and you can see much of New Mexico in general, especially the eastern half or so of the state, saw a drier than normal April for 24. So I heard ERCs mentioned a little while back, so I don't have the most recent stuff. I could pull it off the web if somebody was really intrigued. But this is what it looked like as of late April, early May. And this is just 4 particular predictive services areas that I pulled off here. PSA 1, which is northwestern Arizona. 6 north is kind of the Tano National Forest in the bottom left. Upper right is PSA 10, that's the Sangre de Cristos in northeastern northern New Mexico. And PSA 12 is kind of the Lincoln National Forest down near Ruidoso and Cloudcroft. So let's just look at 12, for example, just for curiosity's sake and for see what that area looked like as of early May. You can see we were right around normal, right hugging that average line, that gray line there for early May of 24 for PSA 12. Since then, in general, most of these PSAs across our region have continued to kind of gone up. Most of them are most of the PSAs right now, from what I saw this morning, we're at the 90th or 97th percentile, notwithstanding a few of them. Northeastern New Mexico was at about the 75th due to recent moisture intrusions. And some areas across the northern tier of Arizona are below the 75th percentile. But many sections of the central portions of the area, like the western half of New Mexico and the eastern half of Arizona, are at the 90th to 97th percentile right now. I'm not sure how pertinent this is as of early June. This is snow water equivalent values. Just looking what went on earlier in the winter time here. April is kind of the central portrait here, where I have that big circle there, a lot of blue there and purple. This was kind of showing we had a pretty decent winter snowpack wise across many portions of the geographic area. You can see many areas of northeastern Arizona did quite well, even bordering into the Great Basin did pretty well. And into New Mexico, generally better across the central sections and southern areas, and a little bit more towards average across the north. And you can see what happened once you got into May, how that drier period in New Mexico in April really, let that snowpack melt pretty readily here. So we went from 232% in the Gila area to about 85% just during that 4-week period in April. So, and of course, if you look to the far north, you can see how dry it was, below average here across that the Washington to Montana corridor, which is not unusual during an El Nino type winter. So with all this, here's kind of the forecast that I put together for late April, from late April for the months of May, June, July, August. This is just a monthly portrait that I do for the rest of the meteorologists in our units across the country. It kind of helps them kind of compare what's going on nationally to the Climate Prediction Center, and kind of gives more of a fire-oriented perspective for climate. So just looking at the month of June here, we got a pretty warm period right now in the short term, but I have the southwest area circled in black here for temperatures here in June. And you can see precipitation is the bottom of that. So in general, I kind of had a normal temperature expectation for many portions of the area for the month of June, and much warmer up here to the east, northeast, and the plains areas. Right now, the situation is actually backwards. It's kind of warmer and hotter to the west, northwest of us, and cooler in the central portion of the country. But I do anticipate this to flip around once we get later into June here. And the expectation for precipitation right now is to be below average here across the southeastern sections of the area, and then kind of near average off to the west, northwest. Looking at the important months of July and August here, which are our monsoonal months, unfortunately, it doesn't look too good for New Mexico, and even my comrades at the CPC in DC agree with this. So kind of a drier tilt, especially across the eastern 3/4 or so of New Mexico into West Texas, and then heading northward into Colorado for July, and kind of perhaps a near average tilt towards Arizona for that month of July. Once we get into August, unfortunately, New Mexico kind of remains likely in a below normal precipitation regime this coming summer, and maybe kind of continuing to be kind of normal off to the west, although I wouldn't be surprised by the latter half or so of August that this actually starts being drier also. So not a great portrait for this monsoonal period this summer, and a lot of heat also as we get into July and August, kind of lingering across sections of the geographic area. So kind of strange, pattern we're in right now, with kind of moisture protruding into the area from the east, northeast, from the plains. That's not completely unusual in early to mid-June, but unfortunately, when you kind of get wet, this early in the season, oftentimes it leads to kind of a depressed monsoon, and I think that's going to be the case this year. And I'm not going to read all this stuff at the bottom here. I kind of just explained it there verbally. This really gets into kind of the geeky stuff here on this present slide here, with kind of the weather pattern portrait for the months of May, June, and then July, August in the bottom left. So I don't want to get into this too much here, but the bottom line is kind of a strange pattern expected to evolve as we head into the month of June. Let's just look at June real quick. This bluish color off the west coast is indicative of a trough of low pressure up there, which I expect to be a mainstay, especially once we get later into June this year. And then an unusual dome of high pressure maintaining itself by especially the latter half of this month across up near the prairie provinces of Canada, up towards South Dakota, North Dakota, Iowa, Minnesota, Nebraska. that's kind of what I'm expecting as we get later this month. So ridging kind of to become more in control of the area, which is not unusual for this month, but still kind of this abnormal breeziness associated with this trough of low pressure off to our northwest later this month. So, we're kind of getting really hot in the next few days with some moisture seeping in from the east, but eventually I think this is going to be swept back into Texas as we get later into June and perhaps starting to get a drier pattern. Which when we're supposed to be getting the monsoon. So that's not necessarily great news as we get into July here. And looking at July, August, looking at some past years, kind of had this type of setup with kind of an unusual kind of onshore flow regime for California, Oregon, Washington. So kind of a coolish and wetter pattern later this summer for the northwestern sections of the United States. And for us, that type of pattern will suppress the monsoon because the dome of high pressure, which we're used to seeing arrive northward up towards the Four Corners and then perhaps into Colorado, Nebraska, and those areas, will likely attempt to make its way that way a few times the next 6 to 8 weeks, but it'll likely continue to be shunted back southward, perhaps hanging right over our area later this July and August. So that's not a great setup for the monsoon. So I do kind of talk a little bit about that. The bar bottom right bullets here, the monsoon near to above normal west in Arizona and near to below average across much of New Mexico. And I say a likely near normal to likely slightly delayed onset, which I still think is probably appropriate for this year. This next slide kind of shows where normally, if you look at, average all the years, the past 2 decades or so combined, the median dates for the end of the large fire season. So normally the large fire season ends in the next 2 weeks or so across West Texas, eastern New Mexico. It ends in central and western New Mexico, typically a few days after the 4th of July. In eastern and central Arizona, right around mid-July, and late July, early August across the western tier of the area. Again, every year is different. 2 years ago, the large fire season ended in just 3 days between the 15th and 20th of June, an early onset for the monsoon. Last year, we were lingering with large fire problems well into August with an unusual wind event around the 8th or so of August. This year is probably going to be more like last year compared to 2022, but maybe a little bit of a better flow in Arizona. That's kind of what I'm anticipating as we head into July and August. And again, I do talk about the ENSO neutral here at the bottom with a possible slide towards La Nina by later this summer and fall. So in summary here, these 5 factors, drought is most significant mainly across New Mexico right now, especially the southern tier. The fine fuels are quite variable. There are pretty good swaths of below normal fine fuels also, but there are a few areas of above normal yields, especially just south of the Mogollon Rim area in Arizona, including the Tano National Forest area, some sections of southern Arizona in the southeast zone, which is the Tucson area. Sections of the Gila and much of the far northeastern plains have above normal yields, and also the Texas and Oklahoma panhandles. Temperature, precipitation, earlier this year, we were in kind of a cooler and wetter pattern, especially west, and milder and drier to the east. And in general, that kind of maintained itself even through the month of April. And most recently, it's kind of become a little bit drier and hotter, especially in Arizona the last 4 weeks or so. Late spring, early summer weather pattern. I'm expecting kind of a continued active weather pattern here, even well into the month of June. We're kind of transferring into kind of a hot pattern, at least the next few days, teasing some early June temperature records, pushing 112 in Phoenix, 113 in Phoenix the next 3 days or so. Almost triple digits in the Albuquerque metro, which is unusual for this early in June. Average high right now in Albuquerque is about 87, 88. So that's about 10, 11 degrees above average. But as quickly as these high temperatures arrive in the near term, they're going to go away and kind of go back towards closer to average as we get into this coming weekend with some moisture pushing into the area from the east. Some downslope wind events likely to continue eventually east of the Mexico Central Mountains, but again, more regular ridging, especially later this month. But again, still kind of this unusual trophy pattern off to our west which I think will not allow the ridge of high pressure to build super regularly over the region, at least until we get into July. Talked about the monsoon a bunch here. Likely on time to slightly delayed this summer, probably near to slightly above normal west and probably below average in New Mexico overall. So with all that, likely a very uncharacteristic and changeable late spring, early summer weather pattern, at least to lead to a slightly delayed onset to this large fire season. Yeah, we've seen some fires already, but we haven't been super active. We were really slow until we got to mid-May this year with not a lot of activity. And I'm going to stop right here, Rachel and Zander, and stop this and try to bring up what I have for the outlook right now. If I can try to find that on, I have it in another window here, if I can try to grab it.
All right,
Okay, here
and
we are.
we are just about at the top of the hour, so if anyone has to jump, we understand, but we will stay on for just a few minutes to wrap up and answer some questions if you're able to stay on at the top of the hour.
So with that real quick, everybody, here's what I had for June for the above normal areas in red: southeastern Arizona, into the Tano area, the Gila area, much of the central mountain chain of New Mexico, into the kind of the Deming, Lordsburg, Rio Grande Valley area. That's for the present month. July, I kept above average here for significant fire across much of central and western New Mexico, anticipating that poor monsoon. Kind of kept that area lingering, unfortunately, into August also. I did tinker with keeping the plains in above average here, but unless we get a lot of wind, those areas are typically not a problem. So I'll recontemplate that as for the late June outlook for August. Did keep many areas of Arizona average here. And I played it safe for September here, but don't be surprised if there's above normal areas of significant fire potential lingering into September this year for sections of the Southwest area. And that's all I have. And unless there's any questions out there.
All right, so we are right at the top of the hour now. So I would just like to thank everybody for being on today. Thank you to Zander and Mike and Rich for your excellent presentations. And like I mentioned, for folks who are able to stay on, we'll go ahead and go through some of those questions that you've been popping into the chat. So the first few have to do with your presentation, Rich. Pepe was wondering, why are some years windier than others? And can you forecast winds for the upcoming fire season, knowing that that's often a significant contributing factor in fire severity and driver?
Yeah, that's a great question. Yeah, I think this information is forecastable. It's not always simple or easy by any means. Everyone jokes that about the weather guys that, why are they talking about 2 or 3 months out when they can't get the weather right for the next 4 days? But in all honesty, the science has improved a lot where you can one thing I do a lot of is I like, for example, what's going on right now with the transition from El Nino to likely La Nina by the fall. I've gone back and I've looked at all similar transitions in the last 75 years. And I've analyzed each of those years individually to try to gauge how this year might shape up. And there's other factors also. I just can't look at those transitions by themselves. I also have to consider other major oscillations globally that are occurring right now that might not or might match or might not match what was going on. For example, in 1964, 1954, 1988, et cetera. Those are some of the other years I was kind of looking at: 2020, 2016, 2010, et cetera. So that's one way I go about it. There's also a lot of climate information you can look at on the internet, but it's also cumbersome, and you can really get hairy really quick, in over your head when you get too involved with this. I found that out definitely the hard way, but yeah, I do think there's a way you can gauge wind and things like that. We are, again, going back and looking at history does show that when you're kind of transitioning out of El Nino to La Nina, it does have kind of a breezier unusual breezier, windier pattern longer than usual through the month of June. So that's something I wouldn't be surprised to see this year.
Okay, thank you so much, Rich. A quick question for Zander and Mike, and this might be asking more about the fact that you've been doing this for years, so kind of reaching back into the past few years of these season overviews. Just wondering if the past few reviews have shed any kind of anecdotal light on the impact of the growing prevalence of invasive introduced grass in lower elevation sites, and how that might be driving fire severity, vegetation, mortality, soil burn severity, things like that. You're muted, Zander.
Classic. That's a great question, and one that I think we really could go back and look at. And it might even be simpler to use the monitoring trends and burn severity data, the MTBS database. But certainly there have been a large number of impactful fires in areas where we don't really expect those kind of fires, saguaro systems, etc., desert systems, where we can make assumptions that it was introduced grasses that are driving it. But I guess the short answer is we haven't done a good job of, say, overlaying that invasives layer with the fire severity. But I think that's something we'll flag for the future. So thanks for bringing that up. And unfortunately, I don't have a great response.
Okay, thank you, Zander. All right, we'll throw one more question out there. And this one is for Rich. Wondering if any of the fine fuel layers take into account multi-year persistence of fine fuels. And in particular, Ellis Margolis, who was on the call, was observing a higher fuel loading of those fine fuels, kind of persisting from 2022 in the area around Santa Fe.
Gotcha. Sorry, I was getting off mute there. You know, I am definitely not a fine fuel specialist. I'm a weather and climate dork. So the information I was getting was strictly from Matt Reeves, who works for the Rocky Mountain Research Station, who produces fine fuel charts for the entire United States. I know he does have some information that kind of spreads over a couple year time frame. I'm not exactly sure how to describe it. So I'm, again, similar to what Zander just mentioned a moment ago. I'm not sure if that's a terrific response or not, but I don't totally understand how he gets his information. I'm just, because it's very detailed and complex.
All right, so it sounds like we have a couple of areas of interest that we might have to follow up on later. So we are a few minutes past the top of the hour, so we'll wrap it up here. Apologies if we weren't able to get to your questions, but we will be sending out a recording of this presentation as well as some additional resources for you all to dig into within the week. Again, thank you so much to Zander, Mike, and Rich for coming on today and giving your excellent presentations, providing all of this good information. And thank you to everyone online who joined us today. We look forward to seeing you in the next one.